All right, let's get into some graphs about this stuff. So remember, there's two ways that we can write exponential functions. One of them is like what's written here, and then also this other one is the 1 plus r. And I mentioned in the last video that if r is positive, we're growing. We'll have 1 plus a number. We'll have a number, b will be bigger than 1 if r is positive. But if we have a negative growth rate, then b will be smaller than 1. But it'll still be bigger than 0. We don't want negative b values. You want to see what happens if we have a negative b value? Right? If we have a negative b value, we get an interesting looking function. It's actually not even graphed. It's wacky. It's wacky. Sometimes Desmos graphs something super wacky, but it's not grabbing it here. Well, that was a little anticlimactic. But yeah, you get weird things. Very weird things. So we'll have only positive b values. So let's look at example 6. Look at some graphs. Which one of these is exponential decay? Look at it from left to right. From left to right, f is going up, f is growing. From left to right, g is going down, g is decaying. Okay, so the decay one has to be g, has to be the green one. It's going down. They're both exponential functions. They both have the same shape, right? That shape that we're coming to see and recognize here with our exponential functions. But one's growth and one's decay. G is decay, it's getting smaller. So for b, if I told you that one of these was 2 to the x and the other was 1/2 to the x, which one would be which? A couple of ways you could do that. If the b value is bigger than 1, it's growth. Here, b is 2. Here, b is 1/2. Well, that answers our question, right? That's f, that's g. Because decay, since it has a smaller b value. We keep halving the function every time x increases. We keep doubling this function every time x increases by 1. So that's, in general, what we're doing here, using what we know about b values. Example 7, I won't have you graph a lot of things by hand, but it's important to get some practice. So there's a couple of ways of doing this. You could make a table of x's and y's and pick a bunch of x's and find out what y has to be. Or you can use what we know about starting values, right? Our a value is 1/2. We're starting at 1/2. And our b value is 2. That means every time x increases by 1, we're doubling. We started at 1/2, increase by 1, we're doubling to positive 1. X increases by 1, that's not a double. We're doubling. Now our y value is 2. X increases by 1, we're doubling. Now our y value is 4. X increases by 1, we're doubling. Now our y value is 8, and so on. So it's kind of like a weird kind of slope. Not actually slope, but it's the same idea. Remember, slope says we keep adding by the same amount every time. Exponentials are the same. We keep multiplying or dividing by the same every time. We can also go to the left. We double going off to the right. We're going to have going off to the left. So this will be a quarter, and this will be an eighth. This will be a 16th. And we'll get really, really close to the x-axis, but we'll never touch it. We get this exponential function. That looks something like this. There we go. That's how we graph. So color overload, let's match each equation with its graph. So, okay, let's look at these pictures first. What do these pictures look like? So these two, green and blue, are both exponential growths, but they have the same starting value, but one's growing faster. These two have the same starting value as well. Oh, one's decay and one's growth. So actually 3 of these graphs are growth and one of them's decay. So maybe we'll start by finding out, well, which one's the decay one? It's a decay if our b value is smaller than 1. So looking at these b values, b value of 1.3, 1.8, 1.3. Ah, here it is. This is the red one. The b value, we're decreasing by 30% every time x grows. We're multiplying by 0.7 every time x grows. Same thing. Okay, so now we got 3 more left, yellow, green, and blue. Well, these two have the same starting value, but this one's got a unique starting value. This one has a starting value of 4. That's going to have to be the yellow. Right? Yellow is the only one other than the red, which we've already done, has a starting value of 4. Now we're stuck by looking at these two, green and blue. They have the same starting value. Which one's growing faster, green or blue? Green is growing faster. Green is increasing faster. The slope is bigger. Green is increasing faster, so it has to be G, because G has a bigger B value. Green is G of X, which makes blue F of X. There we go. That's how you do it. Look at the growth versus decay. See which one's growing faster. See which one has a bigger starting value. Look at all those things. Starting value, growth rate. Is it a decay function? Excuse me. And then you can use that to match these graphs. Let me know if you have any questions, and have a good one.